Good day everybody, welcome to my channel. So today I'm gonna cover two important topics. First, power. If you're going to use BC 250 and create a budget steam machine or for any other purpose, you will need a proper power supply. If you remember from my first video, that was my original power supply I used when was building my first and appeared to be the best steam machine or PlayStation from poor man's dump. This is old Dell 12 volt power supply which can deliver up to 200 watt. The model is D220P. It is rated to 18 amps. It has Dell proprietary connector, which was very easy to adopt to use with PCIe power connector, which we have on the BC 250. Eventually, after doing overclocks and some testing, I realized that this power supply works well if you just game, but if you stress your system, it reaches its limits and it can shut down at times. Therefore, I had to find another solution, and I used another power supply, and this is the brick I'm using now. This is a mean well. You can see the model over here, and this power supply is rated to 252 watt. It has also PCIe 6-pin connector, which perfectly works with BC 250. It can be used. You have to insert it this way. You can leave these two inner pins free and it works very well, or you can use the conversion or converter for 6-pin to 8-pin power supply. Alright, so there are some opinion that one power connector, PCIe connector, can only support up to 150 watt, and I can ensure you that this is wrong. It all depends on the quality of the connector and the wires which you're going to use. As you see, this is original factory 6-pin connector and the power supply is up to 252 watt. Why? Because it was tested by many people. You can find the tests in YouTube, and one PCIe connector with the proper wires can support up to 300 watt. But you need to bear in mind that once you do your job, it can be as bad as this. You have to stress test your board, and you need to check that the wires are not overheating. So later on I will show you recommended way to put a load on the card, and you need to monitor for at least beginning, once you start using your power supply, that the connector and the wires, they are not producing extensive heat. The connector can become warm, but it should always be possible to touch without excessive heat, otherwise it will melt and you can get some troubles. Alright, so it's clear, if you're building the very slim console and you go with the external power supply, you have an option. What to do if you're building a bigger case, or you're on a low budget and you still need to energize your steam machine. Then, well, I'm gonna tell you another extremely budget-friendly option is to use old, used Dell or HP power supply from the servers. So here you can see I have the power supply for 500 watt. It can deliver significant current on 12 volt, but of course you will need to play around to be able to switch it on and to be able to connect it. So as you can see here, I used proper thick wires and I did a conversion. So this is another option. You can energize your board using the Dell or HP old server power supply. They are very cheap. You can find them starting from $10 up to $30, and they are very reliable. They run for years, and it's a good solution, but it's bulky and doesn't look as good as external power supply or other options we are going to talk about. Another thing is that to energize this kind of power supply, you will need to find the schematics for this one to be able to power it on. As you see on my setup, I found the pins. I have a switch, so once I plug it to the BC, once I connect regular 220 cable, I can just flip the switch. It will energize the power supply, and later I can start the console by the power button. Alright. Another thing is, if you're planning to make your own case, I suggest using very compact solution made by the Minwell. This is LOP 312. What it stands for, LOP 300 means that this power supply, I will put a picture of it, that it can deliver up to 300 watt and it gives 12 volts. But it will require you to have some additional cooling. So if you're planning to print a 3D case or build it in the garage, you will need to foresee a small fan which will blow to this LOP 300/12 in order to make it work safely. And you will have to work around to connect the connector to the power supply and to connect this to the power wall. Regarding the cables, as you see, I suggest you need to use proper sized cables to be able to deliver up to 21 amp. I was making the tests. I measure with the current clamps. The under stress test, fully loaded, the BC250 can consume up to 21 amp, which is roughly 240-250 watt out of the power supply. So you need to be ready, and I suggest you to use this kind of connector. It is very good quality with very thick cables. You can use this one to adapt it for your needs and to connect it to the power supply you are going to use. I can tell you that even these sized cables, which are thinner than the recommended one, they work absolutely fine no heat, they are not even getting warm once the system is stress tested. Another option, budget option, which I noticed a lot of people consider, is to use 12-volt LED power supply made for the LED lights. There are many models starting from 100 watt and up to 600-700 watts. They are also very cheap, available in the construction shops, but you need to be careful. The computer power supply has a lot of safeties built in, and LED light power supply may not have it. Therefore, you need to take care. Plus, it will heat. It will heat up, so you need to make sure that you don't pick the power rating of your power supply on the limit. It must have spare, and it must be ventilated. You need to be able to control if it's not extremely hot. You can test it. After that, you can live peacefully, but at the beginning, you need to be careful, all right? Another option, which is very common, is to use just regular computer power supply. It can be big one, ATX, it can be SFX, it can be Flex, doesn't matter. The rule is that you need to check on the sticker of this power supply that it is able to deliver at least 25 amp on 12-volt channel. As I told you, the BC can consume up to 21 amp. This is what I measure myself, and my BC is overclocked to 2000 megahertz at 960 millivolts. If you are overclocking it even further, or your board requires more power to run at 2000 megahertz, if you need to supply 1 amp, 1050 millivolt, then it can pull even more than 21 amp. It can be 22, 23, whatever. So minimum 25, and if you have power supply which can deliver 30 amp, that's fine. You will be fine with that. It must have PCIe connector, or you will have to adapt and make it yourself, and you will have to be able to start computer power supply, you will have to bridge 2 pins on the ATX connector in order to start the supply of 12 volt to your BC. Alright? So the second topic which I'm gonna cover is cooling. As you see here on my second board, there are several ways to cool down your BC250. The original Sony full scale chip is rated to 220 TDP, 220 watt TDP. Our cut down version supposed to be slightly less powerful, and under load, if you're not doing a stress test, what I measured, it can consume 17 amp. 17 ampere of the current, meaning that it's up to 190 watt when it's fully loaded in the game without artificial stress testing. So a lot of this heat is going to the heatsink. So there are several ways to cool it down. As per my opinion, the best, the simplest, maybe not the simplest, but the most efficient way and a cheap way is to spend some time and open the heatsink of the BC in the center and to install 120mm CPU or case fan, and it will supply the air and it will be exhausted from the sides of the heatsink. Few important notices. The fan I recommend as a minimum, if you absolutely have no money and you have few fans laying around, the fan should be at least 1800 RPM. You can set it up in the BIOS, in the custom BIOS, which you can find on my channel, the video and the files. You can set it up and you can adjust the speed of the fan to the temperature to create a curve, but do not install the fan less than 1800 RPM. Honestly, I would suggest to install, if you have to buy one from the beginning, I suggest you to buy Arctic 12 Pro. This fan is PWM controllable and it can run from 600 to 3000 RPMs, meaning that in BIOS you can set up the speed of the fan depending on the temperature of the chip, and it can run quiet once the load is not maximum, and it can actually run faster, drag more air, produce a little bit extra noise, but you will have a lot of spare. Probably it would never be necessary to run the fan above 2000 RPM even in the stress test. But if the fan is able to deliver 3000, you have some spare air, and the fan is cheap. It costs $8 to $10, so I suggest Arctic 12 Pro. Another concern in this situation is that people are afraid that you have here SSD and the hot air is blown passing through the SSD. What I want to tell you is that this is generally true, but the temperature of the chip in this setup when I'm gaming hardly reaching 70 degrees at AAA games, meaning that this is the temperature of the chip itself. Temperature of the heatsink is less, and the air itself, which is blown, what I measured with the gun, the air which is coming out is around 40 degrees. So actually this hot air, which is hot relative to the ambient air, it's still cooling your SSD, because 40 degrees airflow is still colder than SSD when it's fully utilized. So you don't have to worry about that. So with the single fan in the middle, I'm gonna show you now the simplest way how you can cut the heatsink. You need to cut only the part for the fan. Leave this intact because it will help. It creates a channel to guide the hot air. Don't open the heatsink fully and install one fan, otherwise you will have to use aluminum tape or any other way to close it back to guide this air to use the metal of the heatsink. So there are a few simple ways how you can open it. One is with thin pliers. I will show you on the video. You'll have to just grab a small thin piece of steel here and pull it, and it will just rip off exactly by this line very easily. Another option is to use a paper blade from the paper cutter, sharp one. You can really, this is very soft, very thin metal, so you can cut item by item, or some people are using basic nails, scissors, so you can just cut item by item. You will spend probably half an hour, 1 hour, but after that you are able to install the fan and forget about your problems. Second option is actually to install two to open fully the heatsink and install two fans side by side. So some people think that this is twice better than a single fan, but this is wrong. The results of the tests are showing very similar performance as with the one fan, and at some cases it's even worse. Why? If you install two fans exactly side by side to each other, you create the area in the middle where the two fans are contacting each other. You create the area with least of the airflow. So the one fan is cooling left side of the board, another fan right side of the board, and the middle, which has the most of the heat, is actually not having a lot of the drag of the air. So if you would like to open fully the heatsink and install two fans, I suggest that you make a small gap in the between. Like this, the air from the left fan will go left and right, and the second fan will do the same, and in the middle you will have air coming out, and you will have a flow of the cold air, and it will work better than if you will just attach two fans together tightly. Alright? It can work, but I honestly think that this is waste of time. This is proven. You see, I have two similar setups. It works perfectly. In games, my fans are running maximum 1700 RPMs, it's 1600, so they are noiseless, and temperature of the chip is hovering slightly below 70 degrees. No issues with that. But you can do the way you like it. Another option is if you will install one blower here and push air through the heatsink. If you will not open it, you will use a duct. It will be ducting the air. The thing is that because the fan is 120 millimeters, so it's designed to blow through the quite large area. If you are going to guide all this flow through this small surface, you will lose a lot of airflow. The fan will not run as effectively. The system may work, but you will need a much more powerful fan, sometimes up to 5000 RPM, to create enough pressure to have a good airflow through the board. So you will save time. You will not open the heatsink. You will not have to cut anything, but you will suffer from the noise. If you want a good numbers for cooling, you will have to run this fan on that side or that side at much higher RPMs, and it will be loud. I don't like it. I like it to be quiet, and my idea is we don't have to complicate things if we can make it simple. Another thing is, when you're doing the cooling, you can actually remove the original heatsink, fabricate a conversion plate, and install a CPU fan or water cooling system. Honestly, this is too much job, too much time, and if this system works well, I don't know why you have to waste your time for doing this. But if you are interested, you of course can do it. You will have to remember that under this same heatsink, you have the VRAM, you have a lot of MOSFETs which you need to cool as well. So if you are going to remove it, install a cooler. Cooler has to be strong enough, and you need to attach additionally the small heat sinks to cool down the power components, which are also producing a lot of heat. I don't like this idea, but it's exotic and it works as well. Another very important thing is that if you did everything right and you see that your temperature are strangely high, it is possible that thermal interface of your board is actually corrupted. maybe the board was used intensively. Honestly, I didn't experience, and I didn't notice a lot of people who had this issue, but if you would like, you can remove the heatsink and do the repaste. What I suggest is to use Honeywell PTM 7950 on the chip. This is very good thermal phase interface. It is not expensive and it will last forever after you install it. And for the MOSFETs and VRM, you can install the thermal pads, but honestly I suggest a thermal putty. You don't have to think what is the size, 1 millimeter, 2 millimeter of these thermal pads. You just put the thermal putty on every component where you see the originally you had a thermal pads, put it there, it will squeeze and it will touch properly. You will forget after that about any problems. And the last thing about the cooling is actually that the BC250, the board, original board, it has backplate, and backplate there is made to cool down the GDDR VRAM and RAM, which is combined here. It has, you can see here or not, it has thermal pads, and originally the boards, there are many of them in the rack, and strong fans, they're blowing the air, cooling down the heat sinks and the chips through the ducts, and also it's blowing the air through this plate and cooling down the VRAM. So if you are using different cooling method, it's very important to cool down your backplate. So as you see here, I used the body of the case, which is fully aluminum. I attached a passive heat sinks, which are actually radiating, and with some convections they are actually cooling down the GDDR6 VRAM RAM, and it works very well. Under heavy loads you can touch, you feel it's getting warm, but nothing criminal. It works fine. Same I did on my first console. You see I attached a lot of heat sinks like a chest, just to drag the heat out from the backplate to cool down the VRAM and RAM. So please do not forget, one of the options, simple options, is to attach a large heat sink to the back of your BC250, to the backplate. I suggest for this you use the thermal glue. It looks like that. It is also available and cheap. So if you have a large heat sink, you can put in the corners, you can put the thermal glue. In the middle you can apply some cheap and liquid thermal paste, and you can attach the heatsink, and it will passively cool down your memory. I did the same with these small passive heat sinks, and it works very well. Another option for this is to use the backplate cooler like this. You can attach it same like I mentioned, using the thermal glue. You can put in the several spots a thermal glue. In the center you can put liquid thermal paste, and you can attach the active cooler to the backplate of your BC250, and you can use a splitter for your fan, because BC250 has only one connector for the fan, and it's used for the cooling the CPU. It's located over here. So you can buy a splitter for $1 or $2, and you can connect multiple fans to the same PWM controlled connector, and all of them, these fans and these fans, will also operate through the BIOS within the set range. It will all work simultaneously. So if this fan is 3000 RPM and this is 2000 RPM, if you set 50%, it will run half 1500 and this will run 1000. So in this such a way, but they will be controllable, meaning that if its main chip is not too hot, these guys will also run slow. Or if you don't like it, you can just wire it such a way that they will be always on and your backplate will be cold at all times. Alright, so looks like that's it about the cooling and about the power supply. I think if you would have any other questions, you will write in the comments, right? So have a great day and enjoy your fun project. Bye bye. One more thing, guys. I'm gonna show you how to do the test of the cooling and your power supply actually. So for that, you see I'm loaded to my Steam UI. I need to shift to the desktop mode, and in the desktop mode you will require to have two programs installed. The first one is the FurMark. This is very famous GPU testing program, and the second program you will need is the CPU X. Is the basic tool which has a lot of system info, and it has a built-in very simple CPU benchmark. So the idea is that we need to run simultaneously GPU load and CPU load. I suggest for the testing you choose FurMark Vulkan, because this one apparently heats up GPU more than CL version, and in the CPU X you have to navigate to last tab. There you have the CPU benchmark. So after you started the FurMark, you go to the CPU X, you enter the duration of the test. It can be any duration, and you choose 12 threads to load your CPU fully, and after that you start additional benchmark of the CPU to put some CPU load. As you've noticed, one of the benchmarks is fast and another is called slow. So actually the slow numbers, they are loading CPU to 100%. Correct way is to start a slow CPU benchmark. So like that you maintain the board for, let's say, around 20 minutes, 30 minutes, and the goal is to see what the temperature will be on the CPU and GPU. And the rule is that if you are able with your cooling to achieve temperatures below 90 degrees, preferably below 85 in the stress test, that means you're absolutely fine with the games. In the games you will hardly reach 70. If you would like to see the additional sensors data, you open the terminal and you just type sensors. After you hit enter, you will have the snapshot of the current sensors, temperature sensors, and you can easily do the refresh several times and monitor your temperatures. So maintain this test running for 20-30 minutes to saturate this heatsink, and if you are below 90, preferably below 85 in the stress test, in the games you will have no issues. You will be below 70 or around 70. That's it from my side. Thank you for your time, and as usually, like, subscribe, and see you next time.